is Docstring Testing, right? So for the entire semester, I've been diligently writing docstrings that included some example tests. And to be perfectly honest with you, I didn't actually know that these had practical utility. I thought we were just writing docstrings with examples in them to get you guys used to writing. But it turns out this actually has a real use within the system. So today, we're all going to learn how to use the doctest library, and specifically the function testmod. So I want to write, okay, I'm going to move into the terminal now. So the first thing I want to do today is write a function that executes the factorial. You can see that. Yeah, okay, so change directory. Where am I? Where am I? Here. Oh, I hate Mondays. And every day that comes after that's not a weekend. Whoops, I touched Monday twice. I must really love Monday. Okay, so let's get rid of this. Let's write a factorial function. So does everyone know what the factorial is? Okay, it's not just really exciting math. So I'm just going to give you a definition of the factorial. So basically, k factorial is equal to k times k minus 1 times k minus 2 all the way down to 0, 1, right? Where 0 factorial is actually defined to be 1. So what were my docstring tests? I think I had one that said the factorial of 3 should be 6, right? Because it's 3 times 2 times 1 is 6. And the factorial of 0, by definition, should be 1. Okay, so let's write this. And this is a true story of how I wrote this last night, right? So I want to try to make a point that's saying it's a good place to start before writing to decide on a few input-output pairings, because it's going to save you from writing bugs into your code. And this is exactly something I did last night. So I said, okay, I want to write the factorial because I'm so used to writing this recursively that I never write this with a loop. But here, I was trying to write this with a loop. I said answer is equal to 1 for some L in range K, answer times equal L, return answer. So I wrote this, and it seemed perfectly sensible. And then I went over here to my terminal. Okay, so I'm going to show you how to run the doc test on this now. So I'm going to go into Python. Here's Monday. So I have a factorial function. Oh, well, I forgot to write in the base case, but we'll do, oh, no, the base case should work. Factorial of 0, perfect. So we can import this test module, or doc test, and then I can say something like doctest.test my modules. Right? Is this going to pass or fail? So I was really surprised by this, because I thought I had just faithfully implemented a fairly simple algorithm. But it's saying I input 6 and I got 0. Find the error. Yeah.
Range. It should be 1, comma, equals
1. What?
For L in range, it starts at 0.
Yeah, that's the problem. L starts at 0. So the first thing it always does is multiply my answer to 0. And then I can't accumulate by multiplying onto 0. It should actually be this. So true story, writing a doc test actually saved me last night from introducing an error into the lecture. Right, so I'm not telling you to do this because I feel like you're undergrads and I want to waste your time. This is good coding practice, right? Your programs are going to get so sophisticated that you want some insurance that when you make a bug change, for example, if you change a line of code in your program, you want some assurances that your program hasn't broken. So using these doc tests are a good start. Okay, so now that I've written these doc tests, I should be able to go back into Python and run the doc test. And as you see, it said it attempted 2 tests and 0 of them failed. Right, so you're really only going to see printed results if a test fails, which is great because you may get hundreds of tests. If you really want to see the output of all the tests, do you know what it means to be verbose? Okay, this is an English term. Someone who uses 10 words when 2 words would suffice is verbose. It's someone who talks a lot, uses a lot of words. Java is verbose, right? So I can say, doc test, I want you to be chatty. I want you to like talk too much. And then it's just going to show you everything that it tried, right? So it's trying factorial of 3. It's expecting a 6, and it got a 6. It's trying factorial of 0. It's expecting a 1, and it got a 1. So basically, your tests have passed. Oops. Okay, so we're not going to spend the day basically running code through the interpreter, right? What today is supposed to be is a discussion about how does one choose good doc tests in the first place, right? So here's some guidelines, right? Because writing doc tests is a lot like doing integrals. Do you guys know what an integral is? Doing a doc test is like more of an art than it is a science. I can't give you like a list of rules to follow to get a comprehensive list of doc tests. You sort of have to get a feel for what good testing looks like. So here's some guidelines. So a comprehensive doc test, it should test a typical case. It should test an edge case, for which we're going to give a more strict definition. It should test the 0 of the data type. So the 0 of the integers is a 0, and the 0 of a list is the empty list. It should test the singleton of the data type. So the number 1, a list with exactly 1 element in it. Ideally, you want to trigger every if statement in your code. Right? You want to make sure that every single line of the function that you've written gets executed in one of your doc tests. That would be an ideal code. Because otherwise, how good's a doc test that is skipping half of your code? Right? You really want to make sure that every line is executed. You want to be testing for correctness and not violations of the contract. I don't want 600 doc tests saying you inputted this data type, I was expecting this data type, right? Again, we're going to assume that in the final step, we're going to be doing some type checking. So correctness and not violations of contract. And by correctness, I mean you assume that you're given some input that you're contractually obligated to accept, and you're returning the value that your docstring is claiming it's supposed to return. That's what I mean by correctness. And no redundant tests. So speaking of redundant tests, well, let's try to go through this list and see how well we did in our factorial example. So I tested like a typical case. I tested an edge case, a 0, right? Would this be good just to keep going? Okay, just going on a tour, I guess, right? 24? Would there be any use in doing this, right? To keep adding more tests? Why? Yeah, there's really no difference between the factorial of 3, the factorial of 4, and the factorial of 10 in terms of its implementation. If the factorial of 4 is working, we can basically assume that the factorial of 3 is working. So this is what I mean to say that you shouldn't have any redundant tests, right? It's okay to have 3 and 0, because 0 is an edge case. Why would this be a really bad test? Yeah. You don't want your test to run for days. Well, unless your program is some type of super scientific computing type of program, but you don't want to give a really weird, you don't want to have test cases which take forever to run. Because technically you could have edge cases where it's what happens if I give the very largest integer to this? Will I get overflow error? And maybe one day you will have to start thinking about this. But for now, we're really just concerned about testing correctness in edge cases. Okay, so suppose we're given a function, right? And we're not allowed to see what the function has. We're not allowed to see the interior of the function. We can't see how it's written. So I say, okay, so suppose we tasked some high school student with writing the power function, and we need to now use this power function in some mission critical software session, right? How could we gain confidence that this power function was written correctly? Right, this is called black box testing, right? So we're allowed to evaluate power as many times as we would like and investigate the output, right? So what would be good things to try if you didn't trust the person who implemented power? Yeah. Negative is, okay, so I'm just going to implement the power function here. Power. And I'm going to do it in a way I'm going to do it in a recursive way, which means fundamentally this could be unreadable to you guys. So I'm going to do x to the power of y. Why are my colors all screwed up now? Anyways. Okay, I'm going to do it like this. The power with, if y is 0, then return 1. Else return x times the power of x minus 1. Rather, y times the power of x, y minus 1. Okay, so I wrote a routine or a function which calls the function that it's defined to be. Right, so this is a recursive definition. You don't need to understand it. I'm just using it for this example. So if I gave you this power function and you were deeply suspicious that it worked, how could we start? Oh, this isn't going to work. So I didn't write something that's going to work because I don't think this is already going to work for negative exponents. So I'm just going to shut her down and just return this. And then maybe I can just hide the interior. Okay, so like it's basically something like this. We have this power function. I've hidden the inside. So let's go in here and see if it's written correctly. Okay, so let's see. What happens if we say you wanted a negative exponent? Right, okay, cool. Good. So we know that the student has at least incorporated negative exponents. Anything else? 0 is another good one. So we can send this off to NASA now, like no spaceship is going to explode. We've comprehensively tested all of this. Okay, maybe I should change these. Maybe I should just remove the data types, right, to make it more interesting. All right, so what do we got? We got a negative exponent. We got a 0 exponent. Yeah. A fractional exponent. Or maybe a fraction in the base. Yeah, maybe a fraction in the exponent. Cool. All right. I thought that may have been the fire alarm. Anything else? I think, oh, negative base squared. That should give us a even number. Great. Anything else? If you had to bet your first child that this function would work, would you be confident now that it's working? Yeah, let's check that minus 2 to the 3 returns a negative number, as it should. Cool. Right? Because it may have been the case that the code was implemented in such a way that positive answers are always returned. Right? We didn't actually exclude that when we were trying to find minus 2 to 2. So this is good, right? Like you guys are sort of getting the feel for this. Oh, we should try fractions both in the base and the exponent. We should try negatives everywhere. We missed an edge case. Negative 2 to the power of what? 0.5. Oh boy. What the hell is this? Oh, it's a complex number. So we can get complex numbers apparently in Python. Yeah. But we missed one simple edge case. I heard it. Who said it? 0 to 0. Okay, I'm going to try the other one first. 0 to something should be 0, right? I don't actually know what this is supposed to resolve to. Okay, I'm going to guess that this is 1, right? Yeah. Okay, so I think at this point, well, okay, now that we have complex numbers, things get a lot more tricky. Because now we should be trying to put complex numbers to powers and seeing what's happening, right? Okay, so but now you see, so if you ever look through Indeed and you're seeing job postings for like QA analysts, quality assurance analysts and stuff like that, you can get a job in basically writing test cases, right? Because as you see, there could be a lot of them to try to check all of the edge cases, right? So you could have files that are thousands of lines long collecting these type of doc case tests, right? So it is important. It's so important that you can get a job in doing so, right? And writing good doc tests is a good skill. So anyways, that's one of the approaches you can take with writing doc tests for your own functions. Assume you can't see the input of your own function. Or like, better yet, like, you should be writing doc tests for one another, right? And you should try to be like a dick to your friend, right? Just try to write all of the most difficult, try to break your friend's function, right? That's the philosophy you should take when writing doc tests for your own code, right? Try to break your code, yeah. I think that they're going with the physics notation. Yeah. Did we not do that? Negative base, negative power. Yeah, I guess we should have done that as well. And then negative base to odd negative power. And then negative base to like fractional. Like every time you introduce something else new, you have to do all the different pairings. Huh? That should be 0. Oh no, that will be division by 0. Division by 0. Yeah. Because I do imagine that the power is just pulling out the negative, applying the power function, and then just inverting it. So that's why we get a 0. But like, this is good, right? So be your own worst enemy when writing a doc test. Like, really try to break your function. And try to do so beforehand, right? Do so beforehand, and then I'll show you, in next lecture, I'm going to show you how to write doc tests when we can see the code. All right. So is it possible to write a docstring test for every function? I guess I didn't tell you an important nuance, so you can't answer this question. Okay, let me do this one first, and then I'll go backwards to that last slide and re-ask you the question. So what we're doing here is actually called a string test and not a unit test, right? Unit tests are better, right? But we got to learn to crawl before we run. The following tests will fail in this. So I'm gonna pull this. Oh, I forgot to put the intro dots. I'll put them here. Okay, so go away power. If I have time at the end of class, I want to give that recursive definition another crack. Okay, I'm just going to return x, right? This couldn't be more simple as a function. Why is that an x? Oh my god. Okay. Let's read this in. Okay, let's use my identity function. I can just show you, right? Why on earth is this? Oh. Okay. And now let me run the doc test. Whoa. What has happened? Yeah, I heard the correct answer. So some of you clearly know. It's just comparing the strings, the output, right? So I am saying from this function, I am expecting this to return something that, and this is the important nuance, looks like this, right? Looks like it. And as we know in Python, when we print a list, or when a list is printed by the interpreter, it introduces tailing whitespace after commas, right? So this has to be changed to be this. And this used to be this. I'm going to remove it, right? Because an empty list shouldn't contain white space, right? So now I can go out and I can do my doc test, and everything will fail. Exactly as I planned. Right. Okay, what did I do now? Okay, let's try to make this. Hold on. I think that shouldn't be there. Let me try again. Okay, good. Okay, because there is a space here, right? So white space is like the scourge of doc testing, right? So be very important with your white space here. Or you're going to get like walls of incomprehensible error text, right? So just check your spacing. So I think there's actually, I wrote the first 3 lab questions this week, right? One of them basically is fix the white space in this docstring example, right? So be very careful with white space and know that you're just comparing string output. Like, so one way of, and I wouldn't recommend this, but one way of generating a docstring test is just to do this, right? Identity this, identity, 2, 3, 4, and then you can just grab this and put it in here, right? Like doing that is sometimes okay, but it sort of violates the principles that we're using docstrings for, right? You want to predict your output before writing your function, right? You don't want to like write your function and then say it's working because it's giving me the stuff back that I asked it to give it back, right? You'll always pass those doc tests that you copy paste out of the interpreter. Okay, so going back to this question. Is it possible to write a docstring test on a set? Think of what I just told you. I said we're comparing string output. That's it. We're not comparing value. We're comparing strings. Right? There would be another way to do testing where I'm actually comparing to the integer and using equality and determining truth. But we're just determining string equivalence. So knowing that, can I do a doc test for a set? You're saying yes? Why?
Instead of comparing, instead of expecting a certain output of a list in a certain order, or a set in a certain order, you can just make sure that the sets are equal and then ask them.
Yeah, but that's not that's a unit test that you've described, right? Okay, the answer is no, and I'll show you why. Okay. So first, it is possible to do docstring tests on some sets. Why? Well, watch. Here's the set 3, 1, 2. Oh, it prints as 1, 2, 3. Okay, what about the set 1, 3, 2? Oh, that prints as 1, 2, 3. What about the set 2, 3, 1? Oh, it's actually the set 1, 2, 3. Okay, so Python actually has ordered this set, right? Which sort of violates the whole point of it being a set. But nonetheless, so if you have, if the things inside the set have a natural ordering, Python will print with that natural ordering. When I was working at Maple, they decided to order sets like this, and it created a firestorm within the company. People were furious. Okay, here's another one, though. And I want to pick on Drake some more. Drake, maybe I want to compliment them. Drake is so dope. So what? Green? All right, he's a Grinch, right? Okay, look, okay, so I put in Drake is so green, and out came in green Drake is so. Okay, well, this could be good, right? If these sets are returning sorted, that would be a benefit, right? So I'm gonna see what happens when I type in green Drake is so. Oh, Drake green is so is. That sucks, right? So did we converge on something? In any case, there is no method that Python is using to print this set of strings to as output, right? Everything okay up there, mate? Okay, don't need to call the campus health services. Is the bottle broken? You guys would follow me into hell barefoot, I believe, right? If I told you there is extra marks involved, right? Shh. Okay, so if I wrote a function, all it did was return, like if I rewrote this identity function to instead work with sets, right? To expect a set as input, right? So maybe something like this is fine, right? I can say this definitively returns 1, 2, 3, but like, what do I return here? Drake is so green. Like, what do I put? I don't know, right? The Python interpreter has printed out a bunch of stuff in a different order. Like, do I guess that this one's always going to go to that one? I'm not sure, right? So it's not always possible to do a docstring test, right? This is where a unit test would be better, right? Because I say, well, I don't know how the output should look, but I know what the output should be equivalent to. It should be equivalent to this set, right? So set equality would be fine, but strictly speaking, comparing strings won't work here. So there's your example in there, just to show you that, right? Sometimes sets are ordered and sometimes sets are not. We talked about this. Be very careful with spacing, because if you have one white space out of place, it's going to show you incomprehensible walls of error text. And this is why I recommend that you try to set your IDE to actually display hidden characters, right? So I can count that there's exactly 4 spaces there, right? And every time I like tab past 4, it actually puts a line, right? A lot of these little decorations in the IDE are very useful. They keep you programming properly. Except for the linter. The linter is the worst. How much time do we got? I knew this would be a fast one today. Stuff like this is allowed, right? So you actually can like do a bunch of calculations in the docstring and then use that computed value in your doc test, right? So you're free to say something like A is equal to 2, B is equal to 1, take the identity of A plus B, and that's the expected return value is 3. Right, so this is going to be much more useful when we, next time on Wednesday, when we have to start doing docstring testing on more complicated data types like dictionaries and lists, where like the input has to be a little bit bigger. But know that you don't have to like make one giant, really super long line to test something. You can break that long computation up over several lines. Okay, so for the remaining 15 minutes, so because this week I was asked to write the lab examples, a lot of the lab examples are our lecture examples, because coming up with examples is hard, and I didn't want to come up with double the amount of examples. Give me a break. Okay, so in the lab this week, I wanted to sort of pull you guys in my direction and show you that Python can be used for doing mathematics. So I think it has to be the case that all of you are taking calculus. Okay, so I don't feel too bad about asking this question. Basically, given a parabola, given a polynomial that is maximum degree 2, I want to write a function that finds the minimum value of this polynomial over an intended range. Did all those words make sense? Cool beans. Right, so who remembers how to find the minimum of a parabola? Does the word critical point come to mind? Okay, so remember, a parabola either looks like this. Oh, I'm going to have to stand up. Or like this, right? So either the critical point is telling you that you've either found the minimum of the parabola at the critical point, or you found the maximum of the parabola at the critical point. Okay. So I'm not really interested in writing a function to do this, right? Because it's not that hard, right? You calculate the critical points. Well, the one thing I did want to show you is something like this. You can go in here, you can say ABC is equal to this coefficient list, right? Just to decompactify it. And then I can say something like define f of x, which returns ax squared plus bx plus c, right? So you can actually just define, and then you can actually go into here and say, compute f of 1, right? So You can get some utility after defining some helper functions. So I don't know, that's going to return 0. I don't actually care about how this is written. What I do care about is what docstring test should we choose. All right? Because I want you to think. I know that may be hard. But you guys had an extra hour of sleep, so I should get an extra hour's worth of answers from you. I programmed this last night, and I had to delete it from the lab like 9 times, because I kept realizing I was missing edge cases. Then I thought, wait a second, this is a really good example in edge case testing. So the exercise on the lab basically is, I wrote this function, it's mostly wrong, right? Figure out why it's wrong, put in the edge cases that are missing, and write docstring tests for that. Okay, so let's try to write some docstrings for this. So what was one of the first things I said we should test, right? Typical use case scenario. So what's the easiest parabola that I can think of? Well, it's just the parabola x squared. That's the polynomial with coefficients 1, 0, and 0. And if I give it the interval -1 to 1, what should the minimum value of that be? 0. Edge case. What happens when the interval that I'm choosing doesn't include the critical point, which is one of the things I forgot to code for, right? Why? Okay, so what about if I change it to this? Can you still answer? I was asking her, mate, right? 4. Yeah, because don't forget we have to square the input. Right? I chose 1, so I didn't know if you said 1 because you did 1 squared or 1. Anyways, let's move on. What other one should I choose here? Right?
What if A was 0?
Yeah, that's exactly the case that I missed. What happens if A is 0? Right, then the whole finding a critical point is pointless. Right? And then like the entire strategy that I used to answer the question is wrong if A is 0. Because what are we minimizing if A is 0? That's not true.
The lowest point on the...
What is the shape if A is 0? With
It's a straight line.
it's a line, right? So this would be a line. So what is the minimum value of a line on this interval? This one happens to go through the origin. Exactly, -4. What other cases can I get with zeros?
A, B, or 0.
Right? So what's the minimum value in this case?
1.
Right? Because it's a constant function. Help me come up with more. I missed so many last night, it wasn't funny. Right? I was deeply ashamed of myself. Right? What about this one? Yeah, that's the constant function, which is 0. Right? Anything else?
What if A were negative?
I'm not sure that's going to be fundamentally different than, well, I guess we could. We could choose one where A is negative. But that would still be, oh, hold on. It's an upside down one. Okay, I don't know the answer now. What happens when I have an upside down pointing parabola on -1 to 1? The minimum value is minus 1. Yes, yeah. Anyone else? Anything else that you want to do? Okay, so maybe with the remaining time, I'll just code up the function then, right? And then we'll see if our doc tests have run properly. So let's first confirm that these doc tests are correct. So if I have a parabola, if I just have x squared and I'm asking for the minimum on -1 to 1, I get 0. Oh, you know what we didn't do? We didn't try testing the interval. Like, we have to come up with crazy exceptions on the interval. Like, what happens if I'm testing a polynomial over 1, 2, 3, and the interval I give it describes exactly 1 point, right? It's the interval 1 to 1, right? Does your function still work? Anything else? I don't even know what this should return. So I guess here we should return f of 1, right? Because I'm asking what's the maximum of this parabola over a domain which is precisely 1 point, right? So this should return 1 plus 2 plus 3, which is 6. Jeez. And then all variance, right? Then we should really do something like this with a 0 here, right? Just to check that our lines still work when we have these like point-wise intervals. So what about this line? So this line is 2x plus 3. This is going to be 5. Right? Okay, anyways, so hopefully we haven't missed anything. So how can we code this? Well, I think we're going to have to branch. Right? Because I can say something like, if a is 0, then I have a line, basically. So, yes. Which one? Oh. Thank you. Better? Great. Okay, so if a is equals to 0, this is a line. And the minimum of the line is going to be what? I'll make it easier. I'll say we have a left endpoint and a right endpoint. All right, so if we're working on the line, what's the minimum?
Just plug in the left or right so it's small.
Yeah, we want to plug in the minimum of these values. If it's a line, right? Okay, if it's not a line, so at this point I can conclude a is not equal to 0. Right? So I'm not going to write another if statement because it's not required, right? So otherwise we are working on a parabola, so that means I can find a critical point, which happens to be, oh boy, what's the critical point? Minus 2 over, no. It's divided by 2 divided by a. God damn it. We have ax squared plus bx plus c. Therefore, the derivative of this is 2ax plus b, which means the critical point is at minus b over 2a. Okay? Usually people complain when I do this. This is correct, right? Both B and A are on the bottom, right? I knew every time I do this, people get angry with me. This is correct, right? Right? 1 divided by 2 is a quarter, right? 1 divided by, well, I don't know. If you're not convinced by that, but. So like consider it this way, like what's B half? Right? B divided by 2 is B half. And then what's B half divided by A? That's B over 2A, right? You're seeing this as a fraction. It's like B over 2 over A, but that's not what this is. This is 2 divisions happening like consecutively. Okay, well I'm happy the tradition of people getting irritated by this is still alive. But this is a faster way of, like, this is much more, I like this much better than this, right? It, like, allows me to get rid of a pair of brackets, right? But anyways, I'm going to keep it like this. Okay, so we have a critical point. If this critical point is in the interval and f of x critical is less than the left endpoint. Why do I only have to check one of the endpoints and not both? Well, this is a parabola, right? So the critical point means that it's either the global maximum or the global minimum, right? So if anything is smaller than f at x critical, then it has to be the maximum. So I only have to check one of the endpoints and not both. So if it is the case that that statement is true, that means f of x critical is global minima. And I can safely return, yes? F of L. Thank you. See, I already made a small bug in my code, which the docstring would have picked up. Right? If only I can have all of you staring at my code while I program. It would make it a lot faster. Else what? Else, it is the case that it's either not the... Else, one of the two conditions in the if statement had to fail. So it's either the case that the critical point is not in the interval, or that f of x crit is the global maxima, in which case all I have to do, again, is return the minimum of the endpoints. How many of these docstrings do you think are going to pass? Yep. For which one? Oh, I did not return this. Thank you. Okay, you think we'll pass? Let's try, and then I'll let you guys go, right? I couldn't even compile. All right, let's try again. Okay, I'm in. At least we compiled. Okay, so let's try from, import doc test. I have no faith in this, by the way. Test mod. One failure. That's not too bad, actually. And it's a failure at an edge case. Ah! Who sees what's wrong? We're returning a float. Where's the float being introduced? Where are floats being introduced? Huh? Here. Floats are being introduced here. Whoops, no? No, but like what's coming in is x? Oh, I'm dividing. Okay, so I guess I can correct that by... I'll just integer cast this. No, I can't. Okay, I guess we should be returning a float type then, which means all of... Oh. Oh. Nope. No, I'm not. No. I'm just not going to do it. Yeah. Go enjoy your Monday.